Hi, I'm Mr. V, and today we're going to be talking about from illustrative mathematics. Uh, this is Unit 4 on right triangle trigonometry, and we're in Lesson 10, solving problems with trigonometry. The objectives for today, by the end of the day, end of the period, you would be able to say, I can use trigonometry to solve problems. And so what do you notice and what do you wonder? Many people said different things on this. Some things that were said was each of these polygons is inscribed. Each one of them has a radius of 1. The circle is of a radius of 1. Each one of these centers goes to a vertex, not to the side, or not to the center of the side, but to the vertex. And I wonder what the perimeter is. I wonder what the area is. I wonder what this has to do with our lesson today, and why are there getting to be more and more sides? I wonder what you call this one that has 10 sides. It's a decagon. And when we look at this one, what I notice is that these ones, the circle is what is circumscribed by the polygon. So polygon, I mean, inscribed on the polygon circumscribes the circle. And again, they have a radius of 1. And it looks like they're getting closer and closer to being the circle. So that's what we're going to be discovering today. This next activity was on done on Word document, and there were 4 questions. And I'd like to look at maybe 1 or 2 of them. Well, if you look at my responses here, I said, if I cut the square into quarters, and then I can replace it and make 2 squares. And each of the squares, like this would be one square, and then I make another one just like it with 2 of the halves. We know that the diagonal is, this would be a square of side 1, and the diagonal of a square is the square root of 2 times whatever the side length is. So the side length here would be the square root of 2, and if you have 4 of those, that'd be 4 times the square root of 2. Another way of doing this is to make a right triangle out of the radii of the square and see that this makes half a square. So if you were to go like this, make half of a square, and half of a square, like this one here. Anyway, there's several different ways of doing this problem. The second one that we did was the perimeter, and this, I guess, is probably the big one to look at. So let's see if I can copy this over to my whiteboard. Copy? No, it didn't copy. So I have to copy it like this over to the whiteboard. The question is, what is the perimeter of this pentagon? It doesn't give you a picture. You have to draw your own. Maybe you draw a circle, and then you draw 5 dots on it, separate them evenly. That's one way to make a pentagon. And if we're given this is 1, how long is the side length? Because if you take all 5 of the sides, then you can do that. And I'm saying, well, if we divide this into a right triangle, since we've been using right triangle trigonometry, what you're looking for is x. And then 2x is the side length, and then 5 times 2x, which would be 10x, would be the perimeter. And this is the way that you could approach all of these. You could say, well, in a circle, there are 360 degrees. So if I start here and I go all the way around, this would be 360 degrees. And how many of these triangles are there in a 5-gon or a pentagon? Well, there's 5 of them. So if you take 360 degrees divided by 5, that means that that central angle, this angle right here, is going to be 72 degrees. And we don't want this angle. What we really want is this one right here. This angle is half of 72, which would be 36. So if I have a triangle like this, which its top angle is 36, this side length is 1, this is x, this is the opposite, this is the hypotenuse. The sine is what we would use for the hypotenuse. The sine of 36 is equal to x over 1, which is just x. So we can look up the sine of 36 to find out what x is. 2 times x is 1 side length. 5 times 2x would give us the rest of this. And you solve these other problems the same way. There's another problem. Let's see, where is it? Further down. More. Let's see. What's happening to the perimeter as you get larger? So here we have a regular decagon. If I were going to draw a decagon, I would start with a circle. One way to do it. This is not the only way to do it. want to get 10 sides. So I'm going to do a 5-sided thing here. 1, 2, 3, 4, 5. Now I'll cut those in half. And this would give me the decagon. And when you do this, you're going to have 10 triangles if you were to cut it up. So it's going to be divided into 10 parts. 360 degrees divided by 10 would make this central angle here 36 degrees, which means if I make a triangle out of it, my triangle would be a top angle of 18 degrees. And again, we have our x here and our x here. So 2x times 10 sides would be 20 times x would be the perimeter. And this is 1. Again, we have the sine of this time 18 degrees is equal to x over 1. And what we notice is that what we're supposed to notice is that the perimeter of the circle gets closer, perimeter of the polygons gets closer and closer to the perimeter of the circle. So here's an applet which we can explore that shows us what happens when we do this. So if I show the perimeter, and this is actually the same thing that we would calculate when we did this. We got these same numbers when we did the square, when we did the pentagon, the hexagon, and even when we did the tengon. We got the same number, 6.18. At some point, when you get to the third decimal place, it stays the same. So where is that? Let's see then. Let's see, the second decimal place keeps changing and changing. And then it goes 2.6, 2.6, 2.6, 2.6, I mean 0.26. So after you get to 21 sides, it gets closer and closer to the area of a circle. And I mean the perimeter of a circle. The perimeter is 2 pi r, and this is one of the ways that we can use later on to estimate what pi is. So this one is the gentle descent. This is where we used a Jamboard. We would have done this. I don't think we had time for this during class today, but what you have is you have an airplane. It's descending. There's 5,280 feet per mile. And so he has to go 150 miles horizontally and 35,000 feet vertically, which is up and down. And how long is the path of descent? That's how long the hypotenuse is. And what is that angle of descent? And this is a very typical problem. If you're in Omaha and you're coming into Des Moines, you may be at 35,000 feet and have about 150 miles to go. So what is the angle of descent? That's going to make it not too uncomfortable for the people inside. And we were going to do this as a group. So if I were to set up the picture, I would say something like this. Here's the plane. It's got 150 miles, and it's got 35,000 feet. And so your units don't match, so you have to match them up. So I would multiply this times 5,280. Or maybe I would divide this by 5,280. Because when you look at the path, and you want to know this, knowing it in feet probably isn't the best thing. So maybe you divide this by 5,280, or convert it to miles when you're done. So if you do this calculation, this would be the opposite side from this angle. This would be the adjacent side. So we use the tangent to find the angle, we use the inverse tangent of this rise divided by this run. And that will give me the angle. We would look at the work and discuss it. And what do you notice now about this? They get closer and closer to the perimeter of the circle. And then we have this synthesis, which is talking about the area. It's the same GeoGebra file that we looked at before. And here we go, the last thing with area. And this is kind of a fun problem if you think it's almost recreational. What is the area of the circle what is the area of the square inscribed in the circle? When I look at this, I can divide this. If this is 1 and this is 1, this piece right here has an area of 1/2 of 1. And this has 1/2 of 1. And there's 4 halves. So notice I could combine all of these pieces. Maybe move this piece. Well, how did you do it? If I move this piece up here, and I move this piece up here, I can see that going to be 2 long, 1 and 1, and 1 high, so it'd be the area is 2. And that makes sense because the side length here is the square root of 2. So that's kind of what I've got